Today, folks, in today's class, I'll be talking about the complex numbers. Complex numbers. And I'm going to talk about chapter number 12. Now, a complex number constitutes of two parts. It combines a real and imaginary number. Imaginary number. Now, when I combine a real with an imaginary number, that becomes a complex number. Now, what is an imaginary number? So we all know that if I square a negative term, the answer will be positive. If I square a positive term, answer will be still a positive number. But what happens if we have a negative sign under the square root? So this kind of a number is called an imaginary number, and this is represented by symbol J, or sometimes it is also represented with symbol I. So whatever symbol you want to use it, you can use that symbol to represent an imaginary number. So the idea of an imaginary number is same as when we draw any trigonometric function, or for that matter, we draw any point on the coordinate. So this portion becomes y-axis, this is x-axis, and imaginary numbers are represented on the y-axis. So this becomes a representation for imaginary numbers. So j will be negative here. So if I have to represent something negative, it will be represented here. If I have to represent something positive, it will be represented on top here. Alright, so now let's look into more deeply into the imaginary numbers. So if I talk about iota or j, this is equal to square root of -1. When I square an imaginary number, the value will become -1, and then when I take the cube of this number, it's gonna become a -j, and then if I take the j to the power of 4, it's gonna come out to be +1. Now we can always prove this also. So if I look at j, which is equal to square root of -1, this is something you need to remember. And now what we're gonna do is, if I square this number, so -1, so this is -1, and this is square root of -1. I'm squaring this one, it's gonna become -1, and this square root becomes 1 over 2 and multiply by 2, and this is gonna give me -1. Now if I take the cube of a number, so I can write it as j square times j, and j square becomes -1, and j becomes square root of -1, which is, I can rewrite it as j also, and this as a -1. So j cube will become -j. And then if I look at the j raised to the power 4, so that's gonna become j to the power of 2 times j to the power of 2, and this is gonna become -1 times -1, and this is +1. Now if I go to the j to the power of 5, you can write it as j to the power of 4 times j, and j to the power of 4 is what, which is 1, and I'm gonna call it as j as the j. So j to the power of 5 will become same as j, and then the series will start again. So j to the power of 6 will become, this is j to the power of 5, j to the power of 4 times j to the power of 2. Now I can write it as 1 times square root of -1, which is square root of -1 square, means whole of that process which I did here, this down here, and I've already showed you how did I got to this by following this process. So I'm gonna just directly write it as -1 here, -1. So j to the power of 6 will become, j to the power of 6 will become -1. Same way, you guessed it right, j to the power of 7 will be same as j to the power of 3, which is equal to -j. J to the power of 8 will be same as 1, which is same as j to the power of 4, and the process gonna keep on repeating itself. J to the power of 9 will be same as j to the power of 10 will become -1, j to the power of 11 will become negative j, j to the power of 12 will become 1 again, so and so forth. The process gonna continue. Okay, so this was about the imaginary number. So if I ask you a question, what is j to the power of 45? So I can write it as 45. 45 can be 45, it is actually 45. And if I divide into the combination of or the sets of 4, so I can write a j to the power of 44 times j to the power of 1, and which will be equal to, this will be equal to 1, because 44 is divisible by 11. So 11 times 4 is 11 times 4 is 44. I can show you one more time in detail here how I got this value. J to the power of 4 raised to the power 11, and times it by j to the power of 1, and I've used the same exponential rule, x to the power m times x to the power n equal to x to the power m plus n. Based on that, I open this. Actually, it was x to the power of 45, and which I opened it as 44, x to the power 44 times x to the power of 1, x raised to the power 45. That's what I declassified it into. Okay, and now this will be j to the power of 40, j to the power of 4, which is 1 to the power of 11 times 1, and then it will become 1 times j to the power of 1. The answer will be j. Now if I ask you what will be the j to the power of 10, then you guessed it right, j to the power of 8 times j to the power of 2, and then j to the power of 8 will become j to the power of 4 times 2 times j to the power of 2. This j to the power of 4 is 1 square times j to the power of 2. The answer will be negative 1, because j to the power of 2 is negative 1, which we've already proved. Now going back to the complex number, as I said, complex number is a combination of a real number and the imaginary number. So if I wanted to write a complex number, it will look like in this form: a plus bj. This is a complex part and this is a real part. Real, or not the complex, shall I say imaginary part. Imaginary part. Alright, and now if I write a number x plus 3j, I can write it as real part, and this one will become, rather than writing x, I'll write it 4. So 4 becomes the real, and 3 becomes imaginary in this one. Alright, so then there is another thing, how to apply the basic operations on complex number. How to apply basic operations on a complex number. Alright, so we are given, if I wanted to apply addition, okay, on a complex number. So for example, I'm given 3 minus 2j, and then other number given to me is 5 minus 5 plus 7j. I wanted to add these two numbers. Now before I start adding these numbers, I just want to tell you, you can always write 3 minus j2 also, and plus minus 5. This can be written as, the other number was 7, this was 7. So j7, 5 plus j7, which means one and the same thing. There is no difference between the two. Now here I wanted to add the number. So as same as the algebra, whatever we do in algebra, we will add the real part and then we will add the imaginary parts. So 3 minus 5, because there is a negative here, that's why I took 3 minus 5, then minus 2j plus 7j. 3 minus 5 will become 3 minus 5. My computer got stuck, my computer screen. So 3 minus 5 is minus 2, and then this will become minus or plus 5j. That will be answer for the first one. Now let's look into another number. As I said, my computer screen is frozen, so I am trying my best so that it starts working again before I ran out of the space. And let's look into another question. 7 plus 9j and minus 6 minus 4j. This is the question. So I'm going to take the real parts together. So before I take the real parts, 7 plus 9j, I'll open the bracket, minus 6 plus 4j. So 7 minus 6 is 1, plus 9j plus 4, this will be plus 13j. That will be the answer to this question. All right, so let's look into the next one. My video is gonna get halted here for a minute or so, and I apologize for that. Looks like my computer screen is frozen. And okay, so I'm gonna try and work it through. Let's see if I can. Okay. No, anyhow, so I will have to shut it down and then switch it on again. I apologize for this. And let's see. Let me add a new page. Hopefully I'll be able to work now. Okay. I'm not sure why I cannot move the page around. Yeah, now I can. All right. Apologize for the inconvenience. And now let's look into the multiplication of the complex number. Multiplication of the complex number. Multiplication of complex number. X number. All right, so if we are given two numbers, something like 6 minus 2j and then multiplied by 3j. Now how are we going to multiply? Again, same as simple algebra. You're going to multiply 3 with 6 and this with this term too. So 3 times 6 is 18. 18j minus 2 times 3 is 6 minus 6, and j times j, because this is j, this is another j. So 18j minus 6 times j square. J square value is -1. I will highly recommend you to remember this, or you can note down the value of j, j square and j cube and j raised to the power 4 on your formula booklet too, if you wanted to note it down these values. So j square value is -1. So I will put it as -1 here. And now 18j minus minus plus 6. So final answer will be 6 plus 18j. That will be my final answer of this question. Now let's look into another question on multiplication. -9.4 minus 6.2j multiplied by 2.5 plus 1.5j. If a question looks something like this one, how are we going to solve this? So again, as we used to solve those questions, x plus y and x plus 3y, let's say So I'll take the first term, multiply by the complete parenthesis, take the second term, multiply by the complete parenthesis. That's the way I'm going to try and solve this question too. Negative 9.4, 2.5 plus 1.5j minus 6.2j, 2.5 plus 1.5j. And now I'm gonna, if I multiply these two, I'm gonna get a value of negative 23.5. Let me do it one more time on my phone also. So this value will be 9.4 multiplied by 2.5. Yes, this is negative, and negative 1.5 times 9.4, that is 14.1 negative, and the other value will be minus 15.5j, and then this j times j will become j square, and this is j here, and j square. So 6.2 times 1.5, which is 9.3, minus 9.3 j square. Now j square will become a positive 9.3. Why? Because j square is negative 1. So negative 1 times negative 1 will become a positive number. And minus 15.5j, this is minus 14.1j, and this is negative 23.5. Now I'm going to collect the like terms. If I collect these two terms, the solution of these two will be equal to 14.2, and then this will be a negative number, and this will also be a negative number, because both are negative number, and I will add them with the negative sign, 29.6j. So that will be your final answer. So that's how you do the multiplication of complex numbers. All right, let's look into the next question on division of a complex number. How to divide complex numbers. All right, so the first question which I'm going to use is 7 minus 2j divided by 3 plus 4j. This is the number I'm going to use. How to divide? For dividing, it is a little different. Whenever we are dividing the complex number, I need to learn how to take the conjugate of the bottom part of the denominator. Basically, dividing means you are trying to get rid of the iota or j from the bottom. That's what you are trying to do. If you can recall a little bit about your radical expression, so 1 upon square root of 2 plus 3 iota, something like this, or not this actually. uh, so this was square root of 2 minus square root of 3. If the expression is like this and you were to solve this, what you used to do, square root of 2 plus square root of 3, and this one is plus, and square root of 2 plus square root of 3. You were taking the conjugate, means whatever the term is given here, same term but with a different sign. So same process you're going to apply on this one. Here you're going to say 3 minus 4 iota, and or j, 7, not 7 here, this will be, if I'm using this term on the denominator, I have to use the same term on the top. I'm using negative because down here it is a positive sign. So 4 iota, and then 7 minus 2 iota multiplied by 3 minus 4 iota, and on the bottom you're going to use the difference of squares formula. 3 squares minus 4 iota square. A square minus b square equal to a plus b, a minus b. This is a plus b, and this is a minus b, which I have converted into a square minus b square form. Now again my computer screen has frozen, so I'm going to erase it and try to finish it on the same side, and then I'm gonna switch off this video, and then I'm gonna start with another video. Maybe processor is not being able to take all this load right now. So now this will be, so again this is simple multiplication. You will write the first term, 7 times 3 minus 4 iota minus 2 iota multiplied by 3 minus 4 iota. That's what we're going to write on top. 3 square is 9 minus 4j. 4 times 4 is 16. 16 times negative 1, because this will go with this will go with this also. This will become 16j square. J square means negative 1. Negative 1 times negative 16 is positive 9 plus 16. And on top, you're going to get the number as, if you're going to solve, 7 times 3 is 21 minus 28 iota, and then here minus 6 iota, and then plus 8 iota square. And once you're going to solve this one, you're going to get the number as 13 minus 34 iota. This will become a negative number. 8 iota square is minus 1, or j square, whatever you want to call it. As I said, sometimes j is called iota also. So this is j. Iota is represented with the symbol I. If I'm using the word iota, it means I'm talking about the j. So this is the number you're gonna get for this question. All right, so now we're gonna try and take a unique question in which we're gonna try and take the LCM for the complex numbers. So 1 upon j plus 2 upon 3 plus j. This is the question. So how I'm gonna solve this? So I will multiply this one with 3 plus j, and this one on top 3 plus j I have to multiply, and here I will multiply this with j, this with j. So 3 plus j upon 3 plus j times j, same denominator, plus 2j. So this is gonna become 3 plus j plus 2 iota upon, if I open the bottom, it's gonna give me 3j minus 1, because j square is minus 1. So it will be minus 1 plus 3j. On top it is 3 plus 3j. Now if I have to divide, so what I'm going to do, again I have to take the conjugate, minus 1 and then minus 3j, because I don't want to keep any complex number in the denominator. No imaginary part should stay in the denominator. So now this will become minus 1 minus 3j, and then I will just multiply these terms, 3 plus 3j and minus 1 minus 3j, and on the bottom minus 1 square minus 3j square, and then on the bottom it will be 1, negative 1 square is 1, and down here it will be negative 9j square, and then here it will be minus 3 minus 12j. If you're going to solve this, again I'll show you how you're going to solve this. First term multiply by the complete parenthesis, second term multiply by the complete parenthesis. First term multiply minus 1 minus 3j plus second term, and then that will be equal to minus this one was 3j here, minus 1 minus 3j, and then on the top minus 3 plus 9j minus 3j and minus 9j square. This goes with this, and on the bottom 1 minus 9, because j square is negative 1. So this will become 10 on the bottom, and on top it will be minus 3 minus 12j minus 12j. Let me just see, this one is not positive, this one is negative number 3 times this. So negative 12j negative 9j square, which is positive 9. And now positive 9 minus 3 is positive 6 minus 12j divided by 10, which I can write it as 3 minus 6j upon 5, because I've taken 2 common from here. I'll take 2 common from this and divide it with the 10. So this will be my final answer. You can stop here. I will accept this answer too. So this was the introduction of the complex number. So hopefully you were able to understand something out of it. My recommendation to you guys is to try and do exercise 12.2, questions from question number 20, 20 25, 25 to 35, 25 to 35, exercise 12.2. Okay, I'll see you with another video. Till then, good.